Hey guys, here we are. We are in chapter 3 and we're looking at section 3.3 and we're going to talk about slopes of a line. A lot of this stuff you've seen and heard before in algebra, but some concepts do have this crossover habit, right? When we are in geometry. So if you don't know some of the stuff, or and I'm assuming you know some of the stuff, let me know. We'll talk about it together. Let's get started. We're calling it new vocabulary, but hopefully it's old vocabulary. Slope basically refers to the rate of change, right? So in a way, these words are kind of synonymous. Let me get a pen that works. Yeah, so in a way, these words are a little bit synonymous. When we talk about slope, we're usually describing a characteristic of a line, right? So we could have lines on the XY plane that have that are graphed in these different ways, okay? And I'm thinking you remember that each of these slopes or each of the things that you see here has a different representation. So like this is a positive slope. As x increases, y increases. And this is a negative slope. As x increases, y decreases. You can look at it like that. This right here is called a zero slope. And we'll go over this again. And this slope is undefined. Slopes have a numerical value. That numerical value is obtained from looking at the graph and checking out the ratio or the rate of change. So sometimes you may have seen slope referred to as the variable m. You may have seen slope referred to as rise over run. Also, you may have seen slope referred to as delta y over delta x, delta being the Greek letter referring to change when we're dealing with physics and mathematics. So delta y, change in y over change in x, and that can literally be written as, let me try to get a little bit of space. So we would refer to the change in y over change in x as the difference between the y terms of 2 points over the difference between the x terms of 2 points. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So all of these are descriptions that you've seen of slope. Slope is basically the idea of the rate of change, and rate of change is the comparison of one variable to another. Now that we've discussed the vocabulary, let's go ahead to a couple of examples. Here in example 1, we're asked to find the slope of each line. Now, if you remember, we talked about two specific ways of determining the slope of line. One, we call the variable that we use is m. We talk about rise over run. And what this means is how, if I take 2 points, they gave us 2 points. If I take 2 points, I need to figure out how high up and over I go to get from one point to the next. So I'm going up and over. This is going to be a positive slope, as we kind of remember before. How high up? I go up 1, 2, 3, 4, 5. So there's a change for every 5 that I go up. I go over 1, 2, 3, it looks like 4. So my rise is 5, positive 5, and my run is positive 4. So my slope is 5 over 4. That's the ratio. I had to put these together in kind of an odd way. So we're not going to go down. We're going to go to the right to B. So again, I can choose any points. They gave us specific points, so I'm going to use those. But I could have chosen this point here, right? Or any point that I can definitely tell the value of its coordinates. So let's look at L and M. And what I noticed to get from L to M, or from L to M to L, doesn't matter really. If I go down and to the right, a downward movement on the y-axis is negative. So that's going down 1, 2, 3, 4, 5, and 6. So this is negative 6. I'm going to call that a negative 6, a drop. And I move from here to here. That's right. I'm moving to the right, and that's a positive direction. For the x-axis, and that's a positive 3. So if I continue thinking about my slope as rise over run, my rise was negative. Really, when I say rise over run, I'm talking about change, delta y, change in y over the change in x, how the y values change and the x values change, right? Okay, so that's going to show me that I'm going down 6, negative 6. So my rise is negative. It's a drop, or my change in y is a negative change over a positive 3. And when I reduce that, I get negative 2 over 1, or simply my slope is negative 2. All right, and you can see we get a negative slope and a positive slope following what we talked about before. Let's look at part C. Part C, has 2 points here. And if you think about it, there is no vertical change. There is no delta y because the y value stays the same for both of these points. So since there's no change, I have 0 change for y. And now I've got to figure out my run or my change in x. And so my change in x in this case would be to go, let's say, from n to p. And I go 1, 2, 3, 4, 5, 6, 7. And so I go over 7. And so 0 divided by 7 we know to be 0. So the slope here is 0. And you can see it would not matter what point we chose. I could have chosen this point here or this point here. The change in y would have still been 0. The change in x would have been some number. 0 divided by any number is still 0. So it doesn't matter the point once we're choosing points on the line. And over here, let's take a look at this guy. Let's look at Q and R. In Q and R, these 2 points on this line, we need to find the change in y over the change in x. So when I do that, I get that the change in y is, well, let's see, 1, 2, 3, 4, 5. Let's say that's a positive 5 change. And then my run, or my change in x, is nothing because the x values are the same. So I have 5 over 0, and you know what that is, a big problem in mathematics because we are not down with division by 0. So when we have a situation like that, we say that it is undefined. So this slope is undefined, and we talked about that before, right? We did a little bit of a chat up here, and this next graphic is going to confirm that. This is in your textbook. This is a positive slope when we're going up to the right, negative slope down to the right. Straight over, it's a 0 slope, and this is undefined. And if you see me soon, I can tell you a little story about this that's kind of funny with drawings and stuff like that. But I will save your time, assuming that my geometry babies have a really good understanding of algebra. And I'm going to move on to the next example. All right, so we're going to use slope as a rate of change. A pilot flies a plane from Columbus, Ohio to Orlando, Florida. After 0.5 hours, the plane reaches its cruising altitude at 620 miles from Orlando. A half an hour later, the plane is 450 miles from Orlando. How far was the plane from Orlando 1.25 hours after takeoff? And so when I get information like this at 0.5, 620, 4 half hour later, and 450, these feel like ordered pairs to me. So if you notice over here in our chart or our table, it's given as ordered pairs. Anytime we walk up to a chart, we should always make sure we understand this distance that they're talking about is distance from Orlando. It makes sense that as the plane continues to fly, since it's going to Orlando, that distance should reduce until they actually get to Orlando. And so here we see that after a half hour, they were 620 miles from Orlando, Florida. After 1 hour, which was half an hour later after the first half hour, we see that we are 450 miles away from Orlando. How far was the plane from Orlando? 1.25 hours after takeoff. And you can see this dot here refers to that time. I just put that there. Let's do that. So 1.25, or 1 hour and 15 minutes after takeoff, we want to know what this value is. From the graph, we can kind of eyeball it and see that it's going to be somewhere less than 400. But how do we find the exact answer? There's a couple ways to handle this, but the way that we're going to deal with it is we're going to use these 2 points here to figure out what the slope is. Remember how we talked about slope is change in y over change in x, rise over run, all that stuff? We also use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is just the change in y over the change in x. We're going to find the rate of change for this trip, and so we see the time is x value. So if I'm going to use these 2 points, let's call this guy x sub 2, y sub 2, and this one x sub 1, y sub 1. And so it doesn't matter which one we call point 1 or point 2, but we just need to be consistent with the naming, and we can talk a little bit more about that later. So I'm going to, in the numerator, I'm going to write 450 minus 620, all of that over 1 minus 0.5. So we end up with 0.5 at the bottom. 450 minus 620 is going to be a negative number, which does not scare me because I knew I had a negative slope, right? I knew that the distance decreased as time went on, so that's not weird. And I get negative 170 in terms of that change, the difference between these two guys. And so now I'm going to divide this by zero point 0.5, which actually, when you divide something in half, you really double it. Think about that for a second. So this is going to end up being 17 and 17 is 34. So we have negative 340, right, as my the distance that we travel per hour, or the distance that we're losing between Orlando and ourselves, right, as we fly per hour, right? Does that kind of make sense? I hope that that feels okay. So this is miles per hour. And now that we've got that together, I can now figure out, I can say, okay, well, if that's the rate of change, if that's the slope, 340, right, negative 340, then what I need to figure out. So remember we were talking about last time, we said, well, if you take any 2 points on the line, you're going to get the same slope. So I'm going to put this slope aside for a moment, right? I'm going to just move it over here and let's see if we can utilize that idea. So here's this point that we're trying to figure out. And I say we're trying to figure out this point because we want to know what the corresponding distance is going to be. I currently know that this point here is 1.25 comma some y. Let's say y sub 3, right? Some other y value that I don't know about. Well, what I can do is use the same idea. How? Well, watch this. I know that the slope is negative 340. I know that I've got to do change in y over change in x. Now, let's choose to use, I don't know, maybe this point and this point to get the slope, right? Because the slope has to be consistent. So if I use these 2 points that I've highlighted, right, I'm going to get 450 minus y sub 3 over 1.0 minus 1.25, and that has to equal to negative 350 because that too is the slope of the line because this point is on the line, right? All right, so while I'm doing that, I'm going to have to do a little bit of algebra before 50 minus y sub 3, all of that over 0.25, negative 0.25, and again, the negative does not scare me, right, because I understand the thing is going to probably end up being negative. And so now that I know that that's equal to 340, I'm going to multiply both sides by that 0.25. So after I've done that, I multiply this side by 0.25 and this side by 0.25 to get rid of that point, the negative 0.25 in the denominator. I get a positive 85 is equal to this. And now this is pretty easy to solve, right? I'm going to get rid of my 450 on both sides, subtracting them. Once I do that, I get that negative y sub 3 is equal to negative 365. Therefore, y sub 3 has to be equal to a positive 365. Make sense? I hope it does. And here's what I want you to take away from this, that we kind of predicted that the number would be slightly less than 400, and we got that. And we see that the answer is after 1.25 hours of flight, we are 365 miles away from Orlando.